In this video, we're going to be working some Newton's second law problems that involve the friction piece as well. So as I read this problem, how much force must be applied to push a 1.35 kilogram book across a desk at a constant speed if the coefficient of sliding friction is 0.30? Lots of information in this little sentence. So if I look at this, first off, we have this idea of force and applied. So how much force must be applied? So right there, that tells me that that's what we're looking for. So force applied is what we're looking for. To push a 1.35 kilogram book. So this 1.35 kilograms, we know that mass measures kilograms. So we're given this idea of mass. Across a desk at a constant speed. So that's really an important piece of information. Constant speed. That means at a constant speed that my net force equals 0. That's all because of this constant speed piece here. If it wasn't a constant speed, then we would have to find a net force because our motion would be changing. We're also given this idea of the coefficient of sliding friction. So we're given this other piece of information. So mu equals 0.30, and this is our sliding or our kinetic friction. So when we're looking at this, if I have a book sitting on a surface, and I'm going to apply a force. So we want to know what applied force is. I'm going to say the direction that we're pushing this book is going to be positive. So I have an applied force this way that I'm looking for. And we have friction, because we have this coefficient of sliding friction. So we've got some friction here, and I know that the friction force has to be equal to the applied force because of this net force being 0. So when I know the net force is 0, the equation looks something like this. F net equals the force of friction plus the force applied. You'll notice that the force applied is in the positive direction. So we have this positive here, and the force of friction opposes that, so it's in the negative direction. This is 0. So this goes to 0. So I get 0 equals the force of friction plus the force applied. If I take into account the negative sign here, 0 equals negative the force of friction plus the force applied, and I move this force of friction over, then my force of friction equals the force applied. So I'm looking for the force applied. So what I really need to do then is find the force of friction. Well, from last week, or when we were talking about Newton's second law, the force of friction kinetic equals mu times the normal force. The normal force, remember, is the force that's holding the book on the surface. So we have the normal force acting upward, and the normal force is equal and opposite to weight. So we have a way to find the normal force. So our normal force is equal in size, but opposite in direction to weight. So our normal force is mass times gravity. Mu is given to us. So now it becomes a plug and chug. So my force of kinetic friction equals 0.30 multiplied by 1.35 kilograms multiplied by, and in this case, our acceleration due to gravity is 10. We'll just make it 10 to make it easy math. Now remember, we're finding our normal force here, not our weight. And our normal force is in opposite direction. So we could find our weight, and then we would need to take into account the negative sign on the 10 meters per second squared. But because we're finding the normal force, which is in the opposite direction, we don't need to worry about that negative sign. So when I do that math, I get my force of kinetic friction is equal to 4.05 newtons, because I have a kilogram times a meter divided by second squared, which is a newton. And we said that our force applied is equal to our force of friction. So our force applied also equals 4.05 newtons.